Hi, welcome to Fun at Pi videos. This is DC here. This is part 2 of Mifare Classic RFID tags. In this video, you're going to see how to do the basic read and write operations. Now, whenever you buy a new tag, it always comes with the default values. Now, we'll not be interested in the default values of the entire memory. What we have to know is the default values of the key, because in my previous video I mentioned that in Mifare Classic tags you cannot read or write without key authentication. So you have to know the default values of the key, and these values are very well documented in the Mifare Classic datasheet. So I mentioned before that the size of the keys are 6 bytes. So as you can see here, all the 6 bytes have the default value of FF. Now both key A and key B have got the default values as FF. In the first part of these videos, I also mentioned about the access rights. Now every block in this tag has got an access right. Now out of these 4 blocks in the sector, we know that one of the block, that is block number 3, has a special name called sector trailer, and the remaining 3 blocks, that block 0, 1 and 2, these are called as a read-write blocks, or sometimes it's also called as a data block. So there are only 2 types of blocks. One is the sector trailer block, and everything else belong to the same type. Either it's mentioned as a read-write or data block. So for a brand new tag, the access rights of the data blocks, that is the block 0, 1 and 2, it is set to 0. So you're going to see what the value of 0 means. And the access rights for the sector trailer is set to 1. And these values are the same for all the blocks in the entire tag, as well as the keys are the same for all the sectors. Now this configuration, like the 0 and 1 here, this is called as the transport configuration. Now we know that the block 0 is not modifiable, because this is the block that consists of the UID of the tag and some manufacturer specific data. It could be the date and time of this tag or chip is manufactured. So we are going to see how to read and write using different commands. In general, any reader writer you use provides some high level commands. For example, if you want to read the contents of block 2, this is the card specific command. If you look into the datasheet of Mifare Classic, it tells you have to send 30 followed by 02. Or if you look at any reader writer documentation, it says in order to read the block 2, you have to send these type of commands with FF, B0, 00, 0216, and this is also called as the PCSC APDU. And these type of commands, that's the standard commands, works with any reader you buy which are PCSC compatible readers. I would prefer using this method of accessing the Mifare tags. Sometimes some of the reader writers might come with a library. It could be a library in the Java or a .NET library. So that is going to provide a function called read to. So as you can see here, this is the lowest level, this is the next level, and this is the next level. Obviously these type of commands is what most developers or students prefer. So but whatever library you use, eventually the library must convert or send only these 2 bytes to the card. Now, one of the good reason for using a good PCSC reader is the reader handles the auto pooling of the tags. So auto pooling means your reader will be looking for the RFID signal say for example, if this is your reader, so most readers will be in the infinite loop looking for any new tag that enters into its RF field. So this is called as auto pooling. As soon as the reader detects a tag entering this magnetic field, it will send a message to your PC or the software about the new tag. Sometimes it will also send the UID of the tag, and sometimes the card is also prepared for read and write operations. So auto pooling feature is what you would expect from any reader. By having the reader auto pooling, we are going to avoid sending lots of commands to initialize the card. So put in simple words, auto pooling is a nice feature to have in the readers, because this is going to reduce the number of lines of coding programming we have to do. And I'm sure most PCSC readers does have a auto pooling. So I'll be using the ACR122 reader writer. So the reason I'm using this reader writer is, so I have already got a learning software which is already working with the Mifare Classic tags, and there was no proper videos on using that software. So I've taken this opportunity to use that software. So people who have got that software will find it very easy now by following these videos. So I'll be using this software called Understanding RFID Tags using ACR122U. The first thing you do is we connect to the reader. You can see I have got my ACR122U and I've got a brand new the Mifare Classic 1K tag. Now this is the screen that was developed long ago, I would say maybe 2 years ago, and this has got everything you need to understand Mifare Classic tags. So I'll be using this screen throughout this video series. Sometimes I'll also be using a screen from a different version of this software, so just to show you how to write a software like this. So you can see here the software gets the UID of the Mifare tag. So the UID is 4 bytes. So if you see here, the C5 is the first byte, B8 second byte, 5, 6, and this is the UID of this tag. And most tags you buy have got a unique UID. You just have to keep in mind in theory you can find 2 tags with the same UID, because this is a very old tags and the NXP has already manufactured more number of tags than it can fit in 4 bytes. So I don't think that will be any serious problem for the software applications that we develop. So I'm going to first, now as you can see here, you have to authenticate before you read. So I'm going to read all the 4 blocks of sector 0 by hitting this button. So I'm going to show you in my later part of the videos all the commands that are used to authenticate and read the sector. Now here is where you can key in the values of the key A. We know this is the brand new tag and the values of the keys are all FFFs. If I hit authenticate and read, you can see the first 4 blocks are right. Now here there is a couple of interesting information you have to know. We have just read the sector 0, so this column shows the sector number, this column shows the block numbers. This is the block 0, block 1, block 2, block 3, and the columns from B0 to B15 is the 16 bytes of this block. You can see here the first block, this is block 0. As I mentioned in my previous videos, the first 4 bytes are the UID, which is also shown here. This UID, what you see here, is returned by the reader writer. Now this, following that, the B4 is what is called as a BCC, and the B5 to B15 is the manufacturer data. Following that is the access column. This shows the access rights that are set for all the 4 blocks. As I mentioned before, this is a brand new tag. The access rights of block 0 is set to 0. Access rights of block 0, 1 and 2, they are set to 0. The access rights of sector block, if you see here, the sector block or the sector trailer block has a different color. It's a gray color. Now this has an access right of 1. So I'm going to do the same thing and read this, the sector 1. So this reads the content of sector 1. We have read the 4 blocks here of sector 1. You have to keep one thing in mind, and most important thing as well, even though the memory is organized as a sector and a block, every block is given a sequential address. Now this column, the last column, shows you the first block has got address 0, 1, 2, 3, 4, 5, 6, 7. Because when you read and write, in other words, the Mifare tag, the Mifare tag has got a circuitry that will decode all these commands, that does the validation. In order to read and write, you have to pass these addresses. These are called the block addresses. I'm going to do the same thing for the next sector, sector 2. Now this reads all the 4 blocks of sector 2. You can see that the number starts again, continues to 8, 9, 10 and 11. So likewise, if I hit this go button here, this is going to go in a loop. You don't have to hit 16 times. This is the quickest way of reading the entire tag in one single click. And you can see here that this is the Mifare 1K. This has got 16 sector, starting from sector 0 to sector 15. And in here, the last block address is 63. And all these blocks in all these sectors, they all have the default access rights. Now one thing, which the software, probably you might get confused here, is the value of the key A. You can see here it is FFF. This is not readable. So the software shows the value here, because this software was created long ago to make using Mifare Classic easier. But keep in mind, you can never ever read the value of key A. I'm going to show you a different version of this software to make this concept clear. So however, the values of the key B is sometimes readable, sometimes not readable. It all depends on the access rights. Next, I'm going to show you the Mifare Classic 4K. So I've got a brand new Mifare Classic 4K. If I connect here, you get the UID of this tag, which is different. Again, this also has got 4 byte UID. If you now hit this go button, we know that this button is programmed to loop 40 times and bring all the entire data into this software. So because of the memory size, this will take more time. And you can see here, this has got, because it's a 4K, this has got 40 sectors. And if you look at, as I mentioned in the documentation, in the previous video, the sector 0, sector 1, they all have got 4 bytes. They all have the same default access rights. They all have the same default key size as a FFF. And this 4 block per sector goes up to sector number 32, which is the number 31, because numbering starts from 0. Look at the sector 32. The sector 32 has got 16 blocks. Again, the block number starts from 0, 1, 2, 3. The last block, that's block number 15. This is a logical block within the sector. This is the sector trailer for this sector. If you look at the address, the block addresses, it again goes in sequence from 0 to up to, it will go up to 255. So there are 255 blocks in the Mifare Classic 4K, and all the sectors from 32 onwards up to 39, each sector has got 16 blocks. So you can put more memory here. So depending on the application you're developing, so you got enough space to in 4K. Everything else remains the same. So I got some information here. This is a table that provides the meaning of the access rights. So I would like to show this table from the data sheet. So this is the data sheet I got from internet, and I don't think you can download anymore the Mifare Classic 1K tag. This is the Classic EV1, and EV1 is very similar to the Mifare Classic with some additional features. If you go to page number 14, you have got this table which you have to understand every line of this. So this is the access condition for data blocks, and if you go to next page, or probably the page before that, this is the table that explains the access condition of the sector trailer. Now let's go to the simplest one, the access condition for the data blocks. We have seen just now the data blocks has access rights all set to zeros. It is what you saw in the software is a 0. So ultimately now this is stored as a value in 3 bits. This is the 0th value. Now we just have to understand what this line means. Now this is a access rights of a data block. It says how to do this read, write, increment and decrement and these operations. For the time being, I'm not going to worry about these two operations. I'm going to show you or understand the read and write operations. So how do we interpret this line? So in order to read, it says you have to authenticate with either key A or key B. In order to write, you can use either key A or key B. And this line is called as the transport configuration, because this is what the card is configured when you buy a new card. There is a small 1 here, a superscript 1 here, that explains what exactly it is. You don't have to worry about this at this stage, but to put in simple words, what it means is you cannot use key B and start reading and writing if the key B is readable. Now you know that key A is not readable at all. You cannot read key A. So I'm going to repeat again. So what it means here is, if in any configuration, if you are able to read key B, now the question is key B readable? Yes, it is readable in some configuration, But is key A readable? No, key A is not readable at all. So if you ignore this for the time being, if it confuses you, so what it means now is, in order to read the data block with the access right 0, you need to use authenticate using key A. If you authenticate with key B, you cannot read. In order to write, you need to authenticate with key A. Next, go to the data access rights, access rights for the sector trailer. We just saw the sector trailer for a brand new tag is set to this 1, which is 001, and a sector trailer has got three things. It has got the value of key A, the value of key B, and the access right itself. So understand what exactly this row means. Key A, this is a read and write, access rights bits, read and write, key B, read and write. So there are three important pieces of information in sector trailer, and you're going to see which is readable or writable, readable, writable, readable, writable. Take for example the key EA. Can we read key A? You cannot read key A. If you look at that, in all these configurations, the key A is never readable. Now, can you change the value of the key A? Yes, you can write key A, but you have to authenticate using key A. So in order to change the value of key A, you must authenticate that corresponding sector with key A. Keep in mind, we are just discussing the access bits, which is 1. What about access rights, access bits? What about this piece of data in the sector trailer? Is it readable? Yes, you can read as long as it's authenticated with key A. Is it writable? Yes, you can, but you need authentication with the key A. How about key B? Is it readable? Yes, you can read if this sector is authenticated with key A. Look at that, key B is readable, whereas key A is not readable. So this is what that superscript 1 means. The key B is readable. So whenever the key B is readable, you cannot use key B to authenticate. So you'll get this, you'll understand this better in my future videos. What about writing? Can I write to key B? Writing means, can I change key B? Yes, you can change if that sector is authenticated with key A. So I'll be explaining when it comes to the next the different access bits as well. So you have to understand the meaning of these access rights. So probably in my future videos I'll be repeating the same. So if you don't understand at this stage, so don't worry, you'll understand. You'll master this in the next videos. So we have got the access rights of sector trailer, which is 1, and access rights of the data block, which is 0. Now I'm going to show you how to change the value of the data block. Now in order to change, so we are in this line because the data block has got access right 000. In order to write, I need to authenticate with key A. So back in this software, so we are still in Mifare Classic 4K. I'm going to change the value of this block, which is in sector 1. So I first have to authenticate sector 1 with the key A. So this is the hitting this button authenticates key A, hitting this button authenticates in key B. So I'm going to authenticate. Now authentication, this command, this button does two things. It authenticates, plus it also reads the sector. The new version of the software has got a different things here. So I'm not going to see this command at this stage. So I have authenticated sector 1 with key A. I'm going to change the block number 1 in sector 2. So to do that, this software, the only way is go to this tab and key in the values. I'm just going to key in some random numbers. So end with the 30, 31 and 32. I'm going to tab. Sorry, I was wrong here. I have clicked somewhere in a sector 2, because in this software, whatever you click here, the left side is synchronized with the click. So I would like to go, I think the software highlights the sector that is authenticated. The yellow background here is for sector 1. So that's the reason why. So it's because we have authenticated sector 1. So I'm going to click here. As soon as click here, the right button comes. Whereas if we click here, the right button doesn't appear, because the software knows you have not authenticated sector 2. Because we just authenticated sector 1, you can modify all the 4 blocks of sector 1. So click here. So we're going to do the same thing. Say 1 2 1 3 1 4 1 5. So put some random number here, 30 31 and 3 32. If I hit right, now there's a small message here. It says write to sector 1 block 1 OK, and you can see that there's a successful command here. If you look at this command, I mentioned in the early part of the video, in order to write to block 0, look at this a very long command is sent, F000 followed by all these things. Okay, now I'm using the PCC APDU, the direct command. So you're going to understand this in my future videos. So we just modified one of the block of sector 1. To make sure it is read, I can close this thing, connect. I'm going to read just the sector 1. There's a typo here. You can see that the writing was successful. So likewise, you just can't jump in and write something into sector trailer, because sector trailer must be in a fixed format. If you write something different, you'll end up an unusable sector. So for that reason, the software does not let you modify or write or type in the raw data in this sector trailer. The only way you can modify the sector trailer is by playing on this user interface. Because keep in mind, the sector trailer has got no data. There's no application data here, except maybe one of the byte here, that is the byte B9. Only this one can be used for your application data. Everything else is like a controlled data. It has to be written properly. Now most often you'll be writing to sector trailer for changing the value of the key, which can be done using here, or to change the value of the key B, again, which is done using this, and or you'll be changing the access rights, which will be done using to change access rights of sector trailer or access rights of data block. So keep in mind the two things here, the sector trailer access rights as well as the data block access rights. All these access rights are encoded in the byte B6, B7, B8. Maybe in the future videos, it is not very straightforward here. In the future videos, I'll show you how to encode these 3 numbers. I'm going to show you right again. This time I'll be bringing the sector 39. Now you got 16 blocks here. I'm going to write something into the block 9 of sector 39. If you go to data block, So key in some random data. You can also use this this bottom text boxes. I can type the characters. I will type the standard, the hello world. I'm going to put all spaces here. The space is ASCII 20. Going to write. The write is successful. Now there is an option here to look at this data grid in ASCII or hex. If I choose an ASCII, you can see the data written in ASCII, or you can see in the hex. Now in order to write this block, the software has to use the physical block address, which is 249. Just go and see at the command that is used. So this command here, okay, so probably in one of the byte, I would think this one F9, this is the block address of the write operation. So if you convert F9 to decimal, you will get 249. So these numbers, sectors and blocks, they're just a logical number to understand the memory map, but the card or the chip in the card understands only these physical addresses. So in this video you saw how to read and write. You understood about the access write 0 for data block and access writes 1 for the sector trailer. So in the next videos, I'll take you make you understand the different access writes number. Thanks for watching.